This video is the second of a three-part series on the 1630 Bode Frequency Shifter. Part 1, linked above, contains some background information and theory that is critical to understanding Parts 2 and 3. If you have not watched Part 1, it is recommended that you watch that video before watching this video. This video covers the first 4 of 7 applications of this unusual effects module. Now that we have an idea about what a frequency shifter is, let's look at how to use it. We're going to explore the applications documented in the original 1974 Moog documentation for the 1630 Moog Bode Frequency Shifter. Application 1, pitch altering. When the input signal is a quasi-pitched sound, such as that produced by a drum, the frequency shifter will alter the apparent pitch. In the case of a drum sound, varying the amount of frequency shift will appear to change the size of the drum. In conjunction with a 912 envelope follower and a 911 envelope generator, a trigger occurring at the beginning of each drum sound may result in a rapidly varying amount of shift contour, which gives a whole new class of percussion sounds with glide or swoop each time they begin. A drummer may also use a pedal controller or modulating oscillator to vary the amount of shift, thus creating radical changes in the processed sound while he is playing. I'm using the preamp in the 2600, the voltage processor, and the output section, and VCO2 in low frequency mode here. So let's change cameras so that we can see from this angle as well. We have an 8-inch tom, a microphone, and a Bode frequency shifter, and a mixer. Now let's go to picture in picture so that we can see all those things at once. We have a microphone that's being routed to the preamp input over here. It's set to X100 and set at about 2 o'clock on the control. That output goes to this multiple, and this white cable goes into the mixer and then out of the mixer into the signal in of the Bode frequency shifter. This red output comes up and goes into the input number 2 of the output mixer on the 2600. The output of the preamp with the direct drum signal is also going into channel 1 so that we can either listen to the direct drum or the processed signal. We also have this VCO2 LFO output that's routed through this inline attenuator going into the frequency control of the Bode frequency shifter. And we have this orange cable that's coming from the voltage processor that will allow us to apply a voltage without having to adjust these controls. So that's the setup. Now let's go back to our drum camera angle. I'm going to cut off the microphone for a moment so that we can hear the direct signal from the drum. And here's the processed signal from the drum. Another variation of that drum patch is where we take the preamp output, which is normaled into the envelope follower input, and we take the envelope follower output, route it to the lag input, and this is actually a normal connection, so we wouldn't even need that patch cable. And we're taking the output of the lag and routing it into the frequency control of the Bode Frequency Shifter. What that's going to do is use the envelope of the drum hit to modulate the frequency of the shifter, and let's hear what that sounds like. Now we're processing the kick and the snare from a peaks module driven by a Euclidean sequencer, and we're going to turn this switch to 0 so that we're hearing the original unaltered signal. When this light's flashing slowly, we're real close to the unaltered signal. Out of the A output, as we go clockwise, the pitch increases. As we go counterclockwise, it decreases until it goes through 0, and then it begins to increase again. We can also modulate this frequency from the LFO of the 2600. And that's a demo processing a 303 style kick and snare. So that's application number 1. Application number 2, chorus effect and stereo imaging. When an audio signal is shifted by a small amount, a few hertz, and then remixed, interesting chorus effects are generated. The two main outputs may be routed to separate listening channels to create novel stereo effects. Modulation of the amount of shift by a slowly varying control signal enhances the richness of sound and feeling of ambience. So let's set up that mono chorus use case, and what we've got is a voice that's a little bit trumpet-like, and the output of the voice is going into a multiple, which is going to channel 1 of the output mixer on the 2600, and also to the signal input of the Bode Frequency Shifter. We have channel A output in white and channel B output in red. We have channel A output routed to channel 2 of the output mixer on the 2600. Finally, we have two control signals. One is a static offset, which can be controlled by this slider, and the other is an LFO that's going through this mixer so we can attenuate the amount of the LFO. So let's listen to the dry sequence. And we'll mix in the output of the frequency shifter. And now we'll change the amount of shift. And then we'll modulate that amount of shift from an LFO. So that's a mono chorus. Next, we're going to take this separate outputs and route them into the left and right output channels, and listen to it again, and we'll hear the stereo imaging. And that's application number 2, chorus effect and stereo imaging. Application number 3, clang tones using amplitude modulation. A pitch sound which is rich in harmonics becomes clangorous when passed through the Bode Frequency Shifter. When the model SW1630 is used with the Moog voltage-controlled oscillators, it is convenient to control the amount of shift and the frequency of the input signal with the same control voltage. This arrangement produces a clangorous sound whose relationship between overtones, and therefore its perceived timbre, remain constant as the pitch of the sound is varied. Furthermore, exciting new timbres are created when the oscillator tones are dynamically filtered before being shifted. So let's take a look at the setup we've got here. We have a subtractive voice. We're driving it from a sequencer. We have the Bode Frequency Shifter as an effects device. And let's look at the wiring in more detail. First of all, the sequencer is configured right now as an 8x2 sequencer, and the left side is driving the primary oscillator, the program. The output of this is going to a filter and then to a VCA, and of course here we have our envelope generators, and we have a percussive envelope. The other half of the sequencer is driving the internal oscillator, so it's going into control N1 of the shift. We have the output of the VCA going straight into the signal in of the Bode Frequency Shifter. We have the output going to the output mixer on the 2600, and that's what we're listening to. Finally, we have this control in the voltage processor section that's being routed to both frequency modulation of the main oscillator and the control in of the Bode Frequency Shifter, so that we can transpose both of these devices in parallel. The only other thing to note is that we're using the pulse output here, and it's basically square wave. So let's listen to that, and one of the first things we want to do is to modify the cutoff frequency to see what kind of a change that makes, since the filter comes before the Bode Frequency Shifter. Application number 4, Clang tones with FM. Using 2 sine oscillators, one fed into the signal input and the other to a control input, a wide range of frequency modulation is possible. If the amplitude of the control signal is dynamically varied, a class of clangorous tones is produced whose overtone strengths vary over time. Up to this point, we've really been using amplitude modulation through the built-in ring modulators in the frequency shifter. Now we're moving into frequency modulation. Let's take a look at the setup. We're using the triangle output going through the filter and into the VCA. And for the moment, we've taken out the envelope so that we can manually adjust the level. We're also taking the sine wave output from that same oscillator, routing it through a VCA that we're controlling manually, and routing that into one of the control inputs on the frequency shifter. And let's see what that sounds like adjusting the levels manually. Now let's use an envelope generator with a slow attack to do that sweep. Now let's drive it from the sequencer. For this next example, we're using an external sine wave oscillator, which is coming from the filter on the 2600, which is self-oscillating because the resonance is set to the max. We've also routed the CV from the sequencer so that it will track this oscillator. So now our FM is coming through this second VCA, and let's listen to what that sounds like. Now let's modulate that from an LFO that is attenuated here. Thanks for watching to this point. I hope you enjoyed it. This concludes part 2 of a 3-part series on the 1630 Bode Frequency Shifter. In this video, we demonstrated the first 4 of 7 applications of this unusual effects module. Please subscribe to be notified of the release of part 3, the last in the series.